Hi, this instructional video is about ellipses, ellipse, and we're going to identify the vertex and the co-vertex and the focus of the given ellipse. And I'm going to also graph as well. But in order to understand and how to graph, there are some things you need to remember. First of all, the standard form. The standard form of an ellipse is given as x squared over a squared plus y squared over b squared is equal to 1. Now in this case, what we're assuming is on a graph that we have an ellipse where the major axis is horizontal, meaning it's elongated along the x-axis. And what are these a's are the coordinates for the vertex, the vertices, vertex on each side of the ellipse. And so this is called a vertex. Then what is this on the side, the smaller side? Well, that's the co-vertex. And that's represented by the coordinate b. So in this case, this will be a along the y is equal to 0. Then this will be negative a and 0. And this one will be 0 and negative b. And co-vertex on the positive side, on the y, is 0 and positive b. And then, just like a circle, we have a focus. And we will always assume, that for this segment, that the ellipse, the midpoint between the two foci, or the two vertex, will be the origin. Okay? And the focus is given as the c. So in this case, c and 0, and negative c and 0. And this is if the ellipse has a major axis along the horizontal format. Now also, it could be written as x squared over b squared plus y squared over a squared equals 1. In this case, the situation describes when an ellipse has been, as we say, elongated along the y-axis. So the major axis, in this case, becomes vertical. This is the horizontal, and this is the vertical major axis. And so, in this case, the coordinate here now becomes 0 and a. The a always represents the major axis vertex. Then this becomes 0 and negative a. Now this becomes the b and 0. Okay, b is always represented by the co-vertex. So now this becomes the co-vertex. Then this, of course, is negative b and 0. And then the foci is always along the major axis. So then this will be 0 and c. 0 and negative c. Right there. Okay? And how do you find the focus? The form is c squared is equal to a squared minus b squared. The a is always the bigger value. See that? The major axis. So we're going to use this to determine the vertex, the co-vertex, and the focus of an ellipse. So let's keep that over here and try number 1. In this case, if I could write this in standard form in an exponential form for the a and the b, it will be written as x squared is 11 squared plus y squared over 10 squared is equal to 1. And that tells me that the a is 11 and b is 10. And in this case, we will have a major axis horizontally. Okay? Let's see. Let's say this is 10. This is 10. Or this is 11, let's say. And let's say this is 11. So the vertex here coordinate is 11 and 0. Then this will be negative 11 and 0. And let's say this is 10. And then this is 10. So the coordinate for the co-vertices are 0 and negative 10. And this will be 0 and positive 10. And so I could kind of estimate the ellipse shape this way. Now, how do I find the focus? well, we have to use the formula. C squared is equal to A squared minus B squared. See? Right there. And so we're going to plug in the numbers. So if I solve for C, it will be C is equal to square root of A is 11, which was originally 121, minus B is 100. And so C becomes 121 minus 100 is 21, square rooted. And it's 21, what's the square root of 21? 21 is like, what is it? Well, square root of 16 is 4. Square root of 25 is 5. So it must be somewhere in between. Let's just say 4.5 for sake. So that's approximately 4.5. So that'll be around here, let's say. And the coordinate is square root of 21 and 0. And negative square root of 21 and 0. So those are the focus. Yeah. Now I want you to try this one. Okay, so now you realized that the bottom portion, the A and B, is a perfect square. So if you write this again in a standard form with an exponential form for A and B, you can write it as x squared over 3 squared plus y squared over 5 squared is equal to 1. Now this time, the A is smaller, the B is the bigger, so we need to flip them around and recognize the fact that A is now 5 and B is 3. And since the y portion is bigger, when the y is bigger, we're going to have, well, here, let's draw it. Let me put it over here. We're going to have a major axis along the y-axis. It's going to be a vertical major axis. So let's say the A is 5. So let's say 2, 4, 5 right there. 2, 4, negative 5 over there. And 2 and 3 right there. And negative 2 and 3 right there. So if I estimate, it will look something like this. See? Yeah. Okay, if the x is bigger, it's going to be horizontal. If the y is bigger, it's going to be vertical, major axis. So the vertex coordinate is, of course, 0 and 5. This is going to be 0 and negative 5. Those are the vertices. The co-vertices are right there, 3 and 0, and negative 3 and 0. And the focus is always along the major axis. So to find that, we go c squared is equal to a squared minus b squared. And now you see why we have to flip them around. The bigger number always becomes the a. So to solve for c equals square root of 25 minus 9. And in this case, 25 minus 9 is 16, perfect square, which is 4. So the focus is the coordinates right over there at 0 and 4 and 0 and negative 4. So how do you write all this? So we say the vertices, vertices in this case is 0 and plus or minus 5. The co-vertices are given as 3 or plus or minus 3 and 0. And the foci, they're located at coordinate 0 and positive and negative 4. And that's how you write the answer. We didn't have to write the standard form after all because they're already in standard form. There it is.